Welcome everyone to this presentation with the title of SATTSMP Sentiment Analysis Tool for Social Media Posts. This presentation is presented by the Master Student Houda Saib of University of Al-Bouaqi, directed and supervised by Dr. Karima Boussaha of the same university, University of Al-Bouaqi, and Professor Samia Drissi of University Soukharas, all in Algeria in the conference of ICONS 2026 from 16 to 18 of July, hosted in Athens, Greece. Now we start by an overview of our paper. First, we have an introduction, then problem and objectives. Of course, we will talk about research questions, then the state of the art or related work, and then we dive to the core of the paper, methodology and results. We finish by a conclusion and small talking about limitations and future work. Now, coming to the introduction, what is this paper about and what is the topic and the challenges or the problem that we are solving today? First of all, we have more than 5 billion active users or devices across the world that are active on social media. So basically, we have a lot and a huge amount of data circulating, and those data are opinions, emotions, reactions to many different events across the world. Now, the manual analysis there's many and several reasons of why we do it, but it is necessary at the end. But the manual analysis is impossible given the high volume of data. So basically, what we need an automatic system capable of accurately and perfectly interpreting sentiments in real time, which is so important. This phrase, in real time. Now, the challenges we are facing including abbreviations like local dialect, the context, cultural context, emojis, sarcasm, and I emphasize saying sarcasm, which is so important and so hard to treat, and of course the informal expressions. Now, to quite specify our problems, first, we have the first problem, which is building an accurate and usable in real life an accurate system. So, how can sentiments on social media be analyzed automatically? This is the first problem. Coming to the second one, handling the complexity of the language. How can abbreviations, emojis, sarcasm, and all other informal expressions be processed and used? Thirdly, deep learning against traditional approaches or models. So this is so important, a comparison between classical or traditional models and supposedly the most modern and sophisticated models like neural networks and deep learning approaches. Coming now to the objectives. So in our paper, we have three main objectives we want to talk about. First is develop two sentiment analysis systems. The first one is binary classification that contains only the classes positive and negative. And the second system have three classes, positive, negative, plus neutral. Secondly, the second objective is doing what a lot of papers didn't do, which is a comparative, rigorous comparative performance and study. We'll study classical approaches and deep learning approaches. Finally, we make the models accessible. So we take a step further and we make the model accessible through a simple interactive interface using Gradio platform. Now coming to the research questions, we can say that our study have four research questions, namely, is Roberta better than logistic regression and similar traditional or classical models for sentiment analysis? Secondly, which model is the most effective in terms of accuracy and speed? And why we say speed? Because it is in real life and real time. Research question number three, does tweet specific preprocessing such as emojis, hashtags, and emotions, do they improve performance? And we shall see. And finally, is ternary classifications, meaning the second system which have neutral also plus the positive and negative. Is it more difficult than binary classification? We shall see. So our hypotheses are first, Roberta, of course, the deep learning architecture should give us or should obtain better results than classical models such as logistic regression. Secondly, good tweet preprocessing should improve the performance of both models. And finally, using two datasets, not only one, will make it possible to test models in different situations and many cases, and therefore we can say that our results are generalizable and not on a just one case study. Coming to the related work state of the art, we selected the main three works. First, we have Mahkoub and all others studied in 2022. They used Roberta plus GRU. As you all know, it is a model or would say architecture in deep learning, and it is hybrid approach. And BERT, as you all know, outperformed text blob by 15% to 25%, a big difference, but they didn't do a comparison with classical models. Secondly, Tan and all others 2023, they did the same model Roberta plus GRU and achieved 89% 0.59 on sentiment 140. This is the dataset, one of the datasets that we used, and no inference time measurement. So this is really a limitation that many papers suffers from. Finally, Parveen and all others in 2023 as well, they used an RNN plus attention mechanism, achieved 97.86%, a really high and amazing score on sentiment 140. Real-time applicability unfortunately was not evaluated. So basically, what are the problems in existing studies? First, we have few comparison between approaches. There isn't really a rigorous comparison study. Secondly, emojis and special characters and symbols and so on, they are often neglected. They treat just clean text, which is not the case in real life, as you all know. And finally, inference time is not measured, which is really important since this system should be applied in real time. So our contribution to answer these problems, first systematic comparison, a complete pre-processing of all states, and finally inference time measurement. Now coming to the methodology and exactly in the dataset section, like we said, we tried two datasets. First, sentiment 140 that was mainly used in the literature. It contains two classes, positive and negative, with the size of 150 tweets. And we have also tweet eval with three classes, which we used it for the second system, with the size of 15,000 tweets. Now coming to the part of pre-processing. As you all know, we used pre-processing for this or for our study. First, we have cleaning. We clean all unimportant symbols and characters and so on. Then we do normalization. We convert text to lowercase, which is a very common process. Then we do emoji conversion. We take every emoji and we give it, like we change it and convert it to a text and add it to our model. And finally, we take the hashtag segmentations. We split the hashtag sentence into words. Now coming to the evaluation, we took the data. We did data split of 80% training, as you can see in the slide, 10% validation, 10% test to ensure there is no overfitting, underfitting, or anything related. We did really good detailed evaluation metrics accuracy, precision, F1 score, recall, confusion matrix, and so on. The tools used and environment is Python with Colab, libraries such as scikit-learn, TensorFlow, Transformers, and Platform Gradio. And as you can see here, these are some screenshots from the two developed systems. This first is System A. It is binary classification. We gave it a sentence, a case study, great performance by the team today, some symbols, some hashtags, and so on. And our system was perfectly capable of identifying this as a positive case. Even the classical machine learning model was capable of classifying it, but with an accuracy lower than the Roberta model. Now coming to the second system that have three classes, plus the neutral one. As you can see, we gave it another positive text or tweet, and it gave high accuracy, and both logistic regression and Roberta gave comparable results here. So this was very interesting case. Coming to the conclusion, at the end what we can say that the proposal presented is a master thesis project idea. So these results are preliminary. Many results are still in early stages in terms of models development or the obtained results and so on. And in the future steps, what we will do are as follows. In the future, first we will develop the proposed models and compare the results with more models or more traditional models and baselines. Secondly, we also aspire for the developed models to be able to analyze emotions in different languages and local dialects, which is a very important challenge. Furthermore, we aim for the developed models to be able to accurately analyze sarcasm, which is another major challenge, which poses a significant challenge for existing sentiment analysis models. We also aspire for the developed models to be able to analyze sentiments when it comes to understanding language within its context, which is so important to understand the context in general which the sentence or the words exist in, the cultural context or the metadata of the user, and so on. Now, this is it. Thank you all for listening to me. If you have any questions, don't hesitate to ask. Thank you.